Hey, this is Joe. I have not done a recent video on the Oceangate Titan sub accident. I've started to receive some views and comments recently and decided to put a video together with the latest findings that are starting to come out from the U.S. Coast Guard. I'll post a lot of the links and information in the description section of this video. On June 25, 2023, the U.S. Coast Guard convened a Marine Board of Investigation into the loss of the Titan submarine. They refer to this with an acronym of MBI, Marine Board of Investigation. The U.S. Coast Guard has recently released a website on the progress of the MBI and have posted some videos and findings on the Titan accident. Let's take a look at that site. This is the Titan Submersible Marine Board of Investigation website here. I'll put a link in the description of this video. If you notice, there are several categories here. We have hearings information. They had some public hearings in the month of September of this year, and they've posted a link to those videos. They also have some Titan submersible ROV footage. That's remotely operated vehicle. I'll show you some of that. Let's go over and take a look at this link right here, which is the live stream of the hearings. Again, I'll put a link to this in the video. You can also get this link right on the website. Here's a list of the videos. They put together a playlist of all of the hearings, and again, these were public hearings. The MBI is in the process of putting together a final report. When that report is available, I will post another video and publish the link to these findings. Let's take a look at some of that ROV footage. This is again done with a ROV, remotely operated vehicle. If you notice, the depth is going to fluctuate between 3773 and 3775 meters. Converted to feet, that's 12,386 feet. This is a view here. You can see in the distance one of the end caps, the acrylic end caps. It appears to have been blown off. Let's go ahead and play the video and take a look at a little bit of this video. The video is now going to pan over to the remaining section of the Titan sub. As you can see, as we mentioned in a previous video, it appears a lot of people had the same conjecture that the end cap was blown off, and it appears that that is the case. Notice all the structural damage here of the main portion of the sub. I'll go ahead and stop that here. If you want, you can watch, again, by going to the link, you can watch the entire section of this video. There's also a investigation document library here, and there's quite a few links with some various information. A lot of these are PDF documents. Some of them are redacted, some of them are not. And if you go down, there's also some press releases that are listed here. One of the interesting documents that I found was directly from the NTSB. Here's the document here. Again, I'll put references to these links in the description of the video. This is a materials investigation of the experimental Oceangate submersible Titan. We can go through and see that this document was put together by the NTSB, a materials laboratory colleagues, the U.S. Coast Guard Technical Advisor, the Bureau of Inquiry and Analysis for Civil Aviation Safety, BEA, and the BEAMER of France. Also the Transportation Safety Board of Canada. Goes through an outline of what this document contains. There's a bit of a glossary here explaining some terms relating to composite engineering. And there's a few images of some of the processes of how a carbon fiber laminate is laid up using a machine. And this particular machine right here splits prepreg into tapes and tow. Tow is a series of fibers, as you see here, in a continuous strand. Again, it's referred to as a toe. A tape is a flattened portion of toe. Again, some more nomenclature definitions. We get into a section here on hole manufacturing. They've referred to the original Titan hole, version 1. The important thing to notice about this, it was a wet wound in the cylindrical direction. Wet wound or wet winding is taking a section of toe, dipping it in resin, and wrapping it around a mandrel. In this case, a cylindrical mandrel in the shape of the hole here. And then it says pre-preg was applied in the longitudinal direction. Wet wound layups is not as precise as pre-preg. Pre-preg, the resin is pre-impregnated into the carbon fibers, and it's metered much more accurately. Again, they reference the titanium rings that are bonded to each end. It also shows some laminate thicknesses here, and in the version 1, it shows some mid-thickness delaminations. Notice here it shows the circumference and the longitudinal direction. This also shows, and if you look really closely, this is really scary here. It shows some delamination. Notice this dark line right here. This was in between layers. This was in between multiple applied layers. Here's another section in the longitudinal direction, and as you notice, there are a lot of delaminations and what are referred to as voids in the composite matrix, and that are all these dark gashed looking lines. They show some of the carbon fiber. Apparently at one point, instead of titanium, they were making the rings out of carbon fiber. Again, this was in the version 1, and this, I believe version 1 was retired. And this goes into version 2 of the manufacturing process. They show subscale test article failure influenced by wrinkles, and they show some images of that wrinkling. There's also co-bonding, multiple cure process. Usually what that means is first they cure 1 or 2 layers and they let it fully cure or partially cure, and then they come in and usually use some form of adhesive and then put on another layer of laminate. Version 2 was 100% pre-preg. Again, pre-preg is carbon fiber material, usually unidirectional, and that is pre-metered. The resin is pre-metered into the fabric and partially cured, usually stored. The material, once it's been partially cured, is usually stored in a freezer, even though today there are some room temperature pre-pregs. Then the pre-preg material is taken out either of the fridge and warmed up, and then it is they use a fiber placement machine to apply that to some form of a cylindrical mandrel, at least in the case of the Titan. Here is using a fiber placement machine. They mount a mandrel in between 2 points, just like a lathe, and this portion of the machine right up here lays down the carbon fiber pre-preg with a fiber placement machine, and they wrap it around, and in some cases they change the angular direction of this wrapping material to add strength in particular sections of the fibers on the mandrel. They go into some co-bonding and multi-cure processes. Again, they usually have to go many layers thick, so they do multiple applications of the laminate layers, and they usually co-bond, or again, put adhesive between the different layers. Here's a little closer inspection of the hole after it's been trimmed. Here they talk about some V2 hole anomalies, waviness and wrinkles in the trimmed ends, porosity between plies, and voids in adhesive. Again, these are very, very critical errors in the manufacture of carbon fiber. You don't want any wrinkles, you don't want any porosity between the plies, and you definitely don't want any voids in the adhesive. Here's some indications, waviness and wrinkles. If you look at this picture here, a form of waviness and wrinkles indicate that you're going to have voids or gaps in between the different layers of carbon fiber. Here is a side view of some of that waviness. Again, not a good thing for strength. And they indicate here different layers and different wrinkles in the pattern. And this scale here is in inches. Here's a section of the recovered hole, and they're talking about porosity. Porosity is basically a bunch of holes and voids in the carbon fiber laminate. And again, they show this is a recovered piece. It looks like just about 12 inches scale down here at the bottom. And they show, again, this is some of the carbon fiber that was destroyed in the implosion. But if you look closely, you can see a lot of void areas where upon implosion, or just before implosion, you see the voids and the delaminating process of the carbon fiber laminate. Oh, this is a real scary image right here. This is some examples of porosity. If you look, you'll see this lighter colored substrate up here. That is adhesive that was used in the bonding of, again, the multiple layers. And if you see any of the dark lines, these are all voids and delamination. This is really scary right here. See, this is a side view of several laminates. And as you see, any of the darker circled areas here are voids and sections where the laminate was delaminated. Again, this is real scary right here. This is, again, they lay down a section of carbon fiber, and then they come in, then they let it partially cure or even just sit around at room temperature and set up the machine again. They put on a layer of adhesive in between the different layers. And as you see here, they did a very poor job at compacting down the adhesive onto the below layer and the upper layer. Normally what they use a piece of material called peel ply, and they put the adhesive down and then they wrap the peel ply, which is like a plastic film, and they either then vacuum bag it or they put it in an autoclave and they cure it, which under great pressure it's supposed to compress down this adhesive to where there's no voids and or delaminations. And as you see here, you can see that there is delaminations and a very poor application of the adhesive to two different layers of laminate. Again, here's another one, voids in the adhesive, and another scary image here. This is a top view of the greenish looking material is your adhesive. And notice there's a tremendous amount of voids showing straight through where the adhesive did not grip into the carbon fiber laminate. This is really scary right here. Here's a close-up view of that. Notice the fractured adhesive. The little pattern, little lines or pattern in the adhesive is they put this like a plastic wrap material over the top of the adhesive, and then they're supposed to compress it down with either vacuum bagging and autoclave curing, pressure curing. They put the vessel under a tremendous amount of pressure in an autoclave. And as you can see here, the adhesive does not cover the entire portion of the carbon fiber. And all these areas where you see the black of the carbon fiber coming out from the adhesive here are all considered voids, and these voids are in between layers, and this is very, very poor implementation of the laminate structure. They also said that there's some rubbing damage, so probably the hole was drug across the bottom of the seabed floor. The carbon fiber can be very susceptible to abrasion. Again, they call this here some rubbing damage, and they said debris was collected in the voids. As you notice here, this is as recovered here. So notice the crud on that composite material where the actual adhesive was not completely covered over the carbon fiber. Notice in this particular image, they removed some of the debris. Whoops, let's go back here a little bit. Again, here's some microscopic observations here of the rubbing damage. So, hope you enjoyed this video, and we'll see you next time.